Hi, my name is Dinesh Kumar, number TA19115. Today I'm going to talk about metal casting process and the metal that we chosen for the metal casting process. Okay, for the metal selection we have chosen carbon steel. Carbon steel is one of main materials in steel in the casting industry. Carbon steel is amongst the most popular materials in the world of manufacturing due to its incredible properties and low price, leading to it being one of our most used metal in the world. The metal is considered to be carbon steel when it's an alloy of carbon and iron and has no mineral content required for other elements such as magnesium, vanadium, nickel or copper. Typically, this alloy has less than 2% carbon in its composition, varying usually between 0.1 to 0.9 percentage. The mechanical properties of this alloy are determined by the percentage of carbon present. The higher the percentage, the harder and stronger the alloy become through heat treating because they can be processed to obtain a wide range of properties. Carbon steel are found in a variation of application. According to the carbon content, carbon steel are classified as three types. They are low carbon steel, medium carbon steel, and high carbon steel. They are classified by carbon content. For example, low carbon steel has 0.15% to 0.3%. And the medium is 0.3 to 0.6% of carbon content, and high carbon steel has 0.6 to 1.5 carbon content in it. For the low carbon steel, the mechanical properties is low tensile strength and than other steel and is not suitable for heat treatment. For medium carbon steel is more durable and strong. A range of tensile strength are possible with good ductility and shock resistant relativity machine in softened condition. For high carbon steel is strong and has a good shape memory. This alloys steel for high tensile application withstand wear and abrasion and is suitable for high duty application. Low carbon steel are used for bowls, shafts, rods, pins, and more. For medium carbon steel is used for military and defense applications including engine components, coupling and crankshaft, aircraft, tubing, and firearm. For iron carbon steel is used for high duty applications as well, such as cranks and pins. The metal selection, we specifically use medium carbon steel AISI 1040. AISI 1040 carbon steel has medium carbon content 0.37 to 0.44 carbon and can be hardened by heat treatment followed by quenching and tempering to achieve 150 to 250 KSI tensile strength. Its application is this grade of steel is used for fork part, where the strength and toughness of the material are appreciated. C1040 may be used for the manufacture of fork crankshaft and couplings, along with a range of parts where the properties of it treated C1040 are suited to the application. For the metal casting process, we have chosen investment casting. Investment casting, in this case by definition, is means being coated or surrounded. During the process, a plastic shell or ceramic plaster.
Assalamualaikum, my name is Muhammad Shukri bin Abdul Rahman. So today I'm going to present about the process of the steel casting. So the first point is project and design. The starting point for the procedure for making casting is the order received from the client. Initially, it is necessary to study the feeding and filling system of the pieces to be built and make the necessary pattern and core boards. Studies and computer simulation of steel casting solidification are made to ensure the highest quality of the goods to be obtained during the process. The construction of the patterns and core boards, tools used for making sand mold and sand cores, where the liquid steel is poured until solidification is subcontracted to the qualified modelers. The second point is molding and core making section. The sand molds are made in the respective molding facilities. In foundations standard, two technology of sand molding are used, depending on the type and size of the goods to be manufactured. Core making section is an auxiliary molding section and is the part of the process where sand cores are made using the core box. The sand is prepared in the mills and dumped on casting pattern for compaction and compression, shaping the future piece and sand mold. Once the sand mold is compact, the casting pattern is separated and used for making new sand mold. The manufactured cores done in the core making section are placed inside the sand molds in order to determine the inner shape of the workpiece. The next step is the union and closing of the sand molds, and finally the molds are moved to the storage area where the melt steel is poured into the molds. The third one is melting and casting. For obtaining the liquid steel, the scraps and ferroalloys are melt in electric induction furnace of medium frequency placed in the melting section. After the melting process, the steel is downloaded to the ladle and finally the liquid steel is poured into the sand molds, deposited in the casting zone. Fourth is demolding. Demolding of the casting is produced with the separation of the molding sand containing sand of the casting good, operation that is performed by a vibrating shakeout system. As a result of these two parts are separated, the casting good, which will follow the rest of the manufacturing processes, and on the board part, the sand that be used for recycling. The molded steel goods are ready for shot blasting. Fifth is shot blasting. The solid piece or goods as cast are collected in a basket which is subsequently introduced into a shot blasting machine, where the rest of sand that still remain attached to the casting is removed by projecting steel granules. The next is sleeve feeders cutting. After the shot blasting process, the goods are prepared for the next step, the sleeves feeder cutting process, removing the entries and the channels designed from the feeding system of the good. Cutting operations: air gas cutting, arc air electrode cutting, manipulators for feeders breaking. After that is heat treatment. The solid piece as cast part is subjected to special heat treatment in order to achieve the mechanical properties of strength, hardness, and toughness. It is performed standard heat treatment, annealing, tempering, quenching, and hardening in heating furnace to natural gas. The measurement of the mechanical properties achieved in the steel, such as tensile strength, yield strength, impact resistance, and hardness, are made in different tests. Equipment of the mechanical and metallography analysis laboratory. And the next step is deburring. Once the heat treatment is finished, The goods pass to the deburring processes.
Hai, Assalamualaikum. My name Muhammad Hazman bin Syarul Badillah. My matching number TA19149. Okay. Today I want to talk about why my group choose a title of carbon steel. Okay. Carbon steel, however, lacks the corrosion resistant properties of its stainless steel counterpart. Although it is stronger and more durable than stainless steel, carbon steel may rust and corrode when exposed to moisture. Furthermore, carbon steel is less ductile than stainless steel. Okay, second, perbezaan, different between mild steel and carbon steel. Okay, so the difference is the amount of carbon. Mild steel has small amount of carbon between 0.16 and 0.3%. Carbon steel has more carbon, up to 2%, and this allow it to be hardness and tempered. Mild steel is less strong and harder than other carbon steel type. So, the advantage of the carbon steel is durable. Carbon steel is extremely strong and shock resistant. This makes it a popular choice for construction, piping, and to support modern roads. This type of steel is also not prone to rotting as many other metals. Compared to many other material, steel is safe to handle and work it. Okay. So, thirdly, I want to state the weakness of medium carbon steel. Okay, the use of carbon makes iron or steel or stronger by shuffling around its crystal lattice, while carbon steel can still stress and break under pressure. It is less likely to occur than with other types of steel. So maknanya dia tak adalah kuat, tapi kuatlah juga, dia tengah-tengah antara yang terkuat. Begitulah. So the process heat treatment. Heat treatment can only be performed on very thin section. However, additional alloying elements such as chromium, molybdenum, and nickel can be added to improve the steel's ability to be heat treated, and hardened medium carbon steel have greater strength than low carbon steels. However, this come at the expense of ductility and toughness. Okay. So the process. Carbon steel can be produced from recycled steel, virgin steel, or a combination of both. Virgin steel is made by combining iron ore, coke, produced by heating coal in the absence of air, and lime in a blast furnace at around 1650 Celsius. The molten iron extracted from the iron ore is enriched with carbon from the burning coke. The remaining impurities combine with the lime to form slag, which floats on top of the molten metal where it can be extracted. So, for the demand, as a result of their high strength, resistant to wear and toughness, medium carbon steel, and often used for railway track, train wheel, crankshaft, and gear, and machine parts requiring.
Properties of material. AISI 1040. The chemical composition. Any element is carbon. The carbon content is in AISI is 0.37 to 0.44. Manganese is 0.6 to 0.9%. Sulfur is 0.05 percent max. Phosphorus is 0.04% max. For the thermal properties, thermal expansion coefficient at 20 to 100 Celsius. The composition of 0.4 carbon, 0.11 manganese, 0.01 of phosphorus, 0.03 of sulfur, 0.03 of silicon, 0.03 of copper is 11.3. The thermal conductivity is 50.7. For the mechanical properties, the properties density is 7.845. The Poisson ratio is 0.27 to 0.30. Elastic modulus gigapascal is 190 to 210. The tensile strength megapascal is 518.8. Yield strength megapascal 353.4. Elongation by percent 30.2. Reduction in area by percent 57.2. Hardness is 149, and the impact strength is 44.3.
Phase diagram of medium carbon steel in investment casting process. Steels are alloys having element of iron and carbon. Carbon gets dissolved in iron during the production of steels. Pure iron melts at a temperature of 1540 degrees Celsius, and at this temperature carbon readily dissolves into the liquid iron, generating a liquid solution. The individual carbon atoms lie in the holes between the iron atom of the crystalline grains of austenite, which is at high temperature, or ferrite at low temperature. Austenite has the FCC, or face-centered cubic structure, while the ferrite has a BCC, or body-centered cubic structure. Steels having the composition of around 0.76% carbon generate a unique microstructure called pearlite. So this is a phase diagram of the iron-carbon diagram. We use the iron-carbon diagram because it is widely used to understand the different phases of steel and cast iron. Both steel and cast iron are a mix of iron and carbon. Also, both alloys contain a small amount of trace elements. Next is mechanical properties of medium carbon steel. The medium carbon steel, which is from 0.2 to 0.5% carbon, represent bulk of steel casting production. Mostly heat treated by normalizing, which consists of cooling the casting in air from approximately 50 degrees Celsius above the upper critical temperature. A stress relief treatment can be used to relieve stresses set up in the casting by cooling condition or welding operation and to soften the HAZ resulting from welding. And the last one, heat treatment process for improvement of cast steel. In an effort to employ cast steel of a stronger structure than that found in the anode steel casting, the possibilities of heat treatment which will increase the strength without materially decreasing the ductility may be resorted to. The operation of the heat treatment proper will be taken up under the heating of quenching, and drawing. Heating for quenching is best conducted slowly, especially in the case of casting of variable thickness. So in this process, the temperature is controlled. For quenching process, the casting should be transferred as quickly as possible from the furnace to the quenching bath, and in the case of large casting such as locomotive frames, and then the quenching agent employed is generally water or oil, preferably the former because of its cheapness and drastic cooling effect. And the last one is drawing operation, which is done in the bath.